So in this video, I want to talk about scientific notation. And scientific notation is just a way we represent numbers, especially ones that are really hard to work with. It becomes especially useful to use scientific notation for really large numbers or really small numbers. So for an example, let's say I had 37 million of something. We could say 37 million meters, 37 million seconds. Doesn't really matter, but just some really large amount, 37 million of whatever quantity. And so let's say we wanted to do math with it. So of course we'd have to write it out as a number, right? So it's got 6 zeros tacked on to the end of it. And that just becomes really clumsy. So in scientific notation, we can actually write this as a much more condensed number. We can write it as 3.7 times 10 to the 7th. And that's just what scientific notation is. It's just having some number, 1 through 9, times 10 to some power to represent that number. So just to write that out, so the rule for scientific notation. So it's a number, 1 through 9, times 10 to some power. And that's it. And if I just wanted to write that out, I could just do something like this, where the box shape represents the power that I'm raising 10 to. And that power can be negative, and the number 1 through 9 doesn't have to be a whole number, like above it was a decimal, 3.7. And so that's all that scientific notation is. So let's say I did another example. Let's say I had like 457 and I wanted to represent that in scientific notation. Well, 457 isn't a bad number, at least it's not that large of a number and that ugly of a number, but in scientific notation it would just be 4.57 times 10 to the second power. And as another example, let's do 378,000. Why not? So in scientific notation, that's just 3.78, and then you just look at how many decimal places you need to move over. So 1, 2, 3, 4, 5. So it's going to be times 10 to the 5th power. And so that's really how you get the power for the 10, is you just look at how many times, if you were to imagine moving the decimal place from scientific notation, how many times you would have to move the decimal place to get that number. So for example, if the power that the 10 is being raised to is positive, then you just move the decimal place to the right. So for my 457 example, if I wanted to go from scientific notation to the number, you see that I just moved the decimal place once, twice, and then I'm at 457 with the decimal place over here. And that's just what the 2 is representing. That's what powers of 10 do. So as another example, let's say I had 0.0458, and I wanted to put that in scientific notation. So again, we just want some number, 1 through 9, so here it's going to be 4.58. And then we just need to figure out what power of 10 it's going to be. So this time, if we wanted to get from the number in front in our scientific notation to this number on the left, we can't move the decimal place to the left anymore. Instead, we have to move it, or to the right, sorry. Now we actually have to move it to the left in order to get this number on that we have over here. So if I drew, that's 1 decimal place over and then 2 decimal place over. So that's would actually be to the negative 2nd power. And actually, let me write this out a little more clearly. So we have the number 0.0458, and I want to put it in scientific notation. So you know it's going to have to be 4.58, because that's the only number here that we can put 1 through 9. But then when figuring out the power, what I kind of like to do is I sort of, imagine putting zeros in front if I know that the decimal place needs to move to the left. So in this example, I know that in order to get this number, we have to go once and then twice over so that the decimal place is right there. So that's how I know it's 10 to the negative 2nd power. And that's all scientific notation is. It's just a way of making it much easier to work with various numbers. And you can see how useful this becomes, especially when we start dealing with really large or really small numbers.